In this problem, Ryan invests $4,000 in a savings account that pays 3% annual interest compounded monthly. So because it says compounded monthly, we know that we're going to use this formula here for compound interest. It says use the compound interest formula to determine how many years it will take for this amount in his account to double. So we're going to plug in all the values that are given to us. First of all, it says Ryan invests. That means he starts with $4,000. So that's the principal amount. And it says it pays 3%. So our rate is 3%. But 3% as a decimal, we have to move the decimal over twice, is 0.03. And then time is how long. So, whoops, I just noticed I put this in the wrong spot right here. So we're using 0.03 for R. And then N is how many times is this going to occur in the year. And it says monthly. So monthly, there's 12 months in a year. So it's 12 because that's what monthly tells us, how many times. And then it says how many years. That means we don't know. That's our unknown. And we want to know how long will it take for the amount, the end amount, to double. So if we have $4,000, we want to know when will the $4,000 be $8,000. So when will it double? So now we're going to take these values here and plug them into the formula. Okay, so we need to solve this equation, and what you should notice is that the variable is stuck as an exponent. So we need to get the t by itself. So to do that, we're going to start with order of operations, which says do the parentheses first. So if we put that in our calculator, we get 1.0025. And then the next step is in order of operations is exponents, but we can't do this because this is 12t, not 12. So we can't do 1.025 to the 12th power because it's not 12, it's 12t. So we can't do that. But this 4,000 right here is being multiplied. That's what it means when it's next to this parenthesis. So if I want to undo it, I'm going to divide by 4,000 because 4,000 divided by 4,000 makes 1 on this side. And then whatever we do to the right side, we have to do the left. So we would get 2. Okay, now we have the power isolated here. So we know that there is a property with logarithms that says that if we have an exponent that is a variable and we want to remove it from that position, that we could take the log of both sides. So we're going to log the left side, and then we are going to log the right side. And the reason we do that is because there's a property that says this can be moved to the front. It's equivalent. So now we have so to get the t, the time by itself, we have to divide by 12 because that 12 is being multiplied to the t right here. So that's going to make 1. So we're going to divide both sides by 12, but we also want the log, the number that's the logarithm, because that number is also being multiplied by t. So we're going to divide log 2 by 12 times log of 1.0025. So the exact answer for t is this, but that doesn't really tell us, like, how much time is that? That looks confusing to us. So now you're going to go ahead and put it in the calculator. It says round to the nearest hundredths place. So when you put this in your calculator, you should be doing log 2 divided by, And then when you enter it in the calculator, if you're going to put this all in at once, you have to put parentheses in your calculator. If you don't, and on your calculator you just do divide, and you don't put parentheses, and you just type it in like this, etc., it's just going to divide by 12. So you want to divide by this whole thing. So when you type it in your calculator, you should get, it will take about 23.13 years, so a little bit over 23 years for his account, Ryan's account, to double to make 8,000.